You are welcome to today's class on techniques of integration. In the last class, we talked about differentiation. How do you differentiate? The power function rule, the constant rule, the sum and differences rules, and so many others. Now we are in integration. How do we integrate? Integration is the opposite of differentiation. You can call it integration or you call it anti-differentiation. For instance, in differentiation, if you are to differentiate x raised to power 2, you say that equals to this 2, you bring it to the front to be 2x raised to power 2 minus 1, which equals to 2x. Then 2 minus 1, 1, which will give us 2x raised to power 1. This is differentiation. But when you are now looking at the opposite side of this, it becomes what? Integration. As you have, if you are to, what is the sign of integration? This is the sign of integration. If you are to integrate this kind of equation, 2x dx, what will you have? If you are to integrate this, after integrating this, you must get back this your differentiation, which we now say, what is 2x? 2x. You want to integrate this. This means that this is raised to power 1. 1 plus 1 will give you 2. You now say 1 all over 2. Then what do you have here? You have 2s. We have 2s. 1 plus 1. We now have plus c. This will now give us 1 all over 2. 2x. 1 plus 1, 2 plus c. This cancel this. You have only s raised to power 2 plus c left. Now you have gotten your s raised to power 2 back. This is what we're actually referring to in integration. That is why we call it the opposite of differentiation or anti-differentiation. We move. There are some key things we have to know in differentiation before we go in further. We have k, which is properly known as our constant. K equals to what? Constant. As we have it to be c or that. We have the constant. Then what else do we need to know? This sign, which you don't have it in differentiation. We have this sign. This sign is known as what? Equals to what? Integral. That sign is called the integral sign. And then what else do we have? We have what we call integral. What is our integral? If we say f in bracket x, this is called what? Integrand. That is called what you know as what? Integrand. Now with this we can move further. The integrand of a constant k, for instance, when we have integral k dx, integral k dx equals to what? Kx plus c. For instance, when we have the integral of 1 written simply as the s, if we have the integral of 1, for instance, integral ds equals to what? X plus c. X plus c. We don't write 1, we write the x. This integral ds is like integral 1, but we don't normally write 1, we use x. So that's it. Integral ds equals to x plus c. We go to another integral, the integral of a power function. How do we write the integral of a power function? A power function, a power function such as n raised to power s or s raised to power n or s raised to power n. This is a power function. This is a power function where n is not equals to minus 1. Where n is not equals to, this sign means not equals to. This sign simply means not equals to. Where n not equals to minus 1. How do we write this kind of function? Let's solve. For instance, integral s raised to power n dx. How do we solve this? Integral s raised to power n dx. How do we solve this? This is n. You now says that this equals to, this one will be 1 all over, what is here? N plus 1 x n plus 1 plus c. This is how to write down this equation. S raised to power n, when it comes here, it should be 1 all over. it will be 1 divided by the n plus 1. If you recollect, in differentiation, we normally minus from the power function. But in integration, we add. That is why we said integration is the opposite of differentiation, and it's also known as anti-differentiation. We know 1 all over n plus 1 x raised to power n plus 1 plus c. That is our answer there. Then we move on. Now let us take the first example. In the first example here that we'll be looking at, EG1. EG1 says that solve EG1A, say solve integral 3 dx. Solve integral 3 dx. What will integral 3 dx going to give us? Integral 3 dx. This integral 3 dx, nothing is here. We say solution. Integral 3 dx will give us 1 all over, what is here? Nothing, 1, 3x. Now give us 3x plus c, which equals to 3x plus c. That is the integration of 3 dx. In 1b, 1b says that solve integral x raised to power 2 dx. Solve integral x raised to power 2 dx, we come here by saying solution integral x raised to power 2 dx. What will it give us? This one, when it comes here, I say it will be 1 divided by, what is here? 2. 2 plus 1 x raised to power, what is here? 2. 2 plus 1, which equals to 1 all over 2 plus 1, 3 x, 2 plus 1, 3 plus the constant. This is the answer we have there, 1 over 3 x cubed plus c. We move to example 2a. Example 2a says that integrate 3x raised to power 3 minus x plus 1 bracket close the x. Now, how do we integrate this? This is 3x cubed. This is 3. Bring the 3 out. 3 integral x raised to power 3 minus integral x plus integral 1. As I've told you, when we have integral 1, you just say equal to integral dx. This is what we have here. Then this is 3 in brackets, x raised to power 3. When this 3 comes, it will be 1 all over 3 plus 1, 4. So you get 3 plus 1, x raised to power 3 plus 1, bracket close, minus this. It means it's raised to power 1. When it comes here, it will be 2. 1 all over 2, x raised to power 1 plus 1, plus, what is it? Integral the s will give us what? Plus x. We now have plus the constant c. This will now give us 3 in bracket, 1 all over 1 plus 3, 4, bracket close. S raised to power 4 minus 1 all over 2, s raised to power 2, 1 plus 1, 2, plus x plus c. 1 times 3 will give us what? 1 times 3 will give us 3. That will now give us 3 all over 4, x raised to power 4 minus 1 all over 2, x raised to power 2 plus x plus c. This is our final answer there. We move on to the next example. Next example, which is example 2b. 2b says that solve integral 3x raised to power minus 1 dx. Solve. Now this is 3. We say 3 integral x raised to power minus 1 dx. Now, what do we do here? When we are solving this, this is 3. We now say 3 in x, 3 in x plus what? Plus c. The 3, x is for minus 1 will give us in x plus c. That is the constant. Now, we want to move. After all this, we want to move to integration by substitution. How do we solve questions on integration by substitution, whereby we are to substitute? How do we solve question on integration by substitution? For instance, under integration by substitution, we have integrate 12x raised to power 2 in bracket x raised to power 3 plus 2. Now, if we want to solve this, how do we solve this in integration? Integrate 12x raised to power 2 in bracket x raised to power 3 plus 2, let's see the x. Now, how do we solve this? The first thing you have to know here is that integral f dx, f of x dx equals to integral u du all over the x in bracket the x. Now, if we have this, what is our u? The first thing is to identify our u equals to x cubed plus 2. X cubed plus 2. Then what is the u dx here? The u dx here, when you differentiate this, it will give you 3x squared. That is our the u dx. Now that we now have 3x squared as our u dx, we can now move further by saying integral. When we say integral, what is here? 12x raised to power 2 dot u, that is our u, dot the u dx. What is our the u dx? That is 3x squared. Our the u dx is 3x squared. This is where majority of the people used to get it from. You now say the u all over 3x squared. Now, 3x squared here 1, 3x squared here, in 4x squared will give us 4. We now have integral 4 dot u dot du, which equals to integral 4u dot du, or 4u du. Now that we now have 4u du, how do we solve further? Now, we move further by saying that this 4 will come out 4 integral, what is it? U, which means before you write, u is raised to power what here? Power 1. 1 plus 1 will give us 2. 1 all over 2 u, 1 plus 1. Then we should now give us 4 in bracket 1 all over 2 u raised to power 1 plus 1, 2 bracket close. When we now say bracket close, we can now have our what? Plus c, which is the normal constant. 2 here 1, 2 here 2. 2 times 1, 2. We now have 2 u raised to power 2 plus c. Therefore, 2 in bracket, what is our u? We now say, what is our u? Our u is x cubed plus 2 bracket close raised to power 2 plus c. Now that we have your 2 here, 2u, 2 in bracket what? X cubed plus 2 plus c. That is our answer. You see some people say multiply by, okay, 2 times 2x cubed, 2x cubed plus 4 raised to power 2 plus c. You see some people writing like this, but it is better in this way. Now we move to another example. The other example we have here is integrate 10s in bracket s raised to power 2 plus 3 bracket close raised to power 4 dx. Now, solution. We said the first thing, as we know that x squared plus 3, our u equals to what? S cubed plus 3. That is our u. Then we say u raised to power what? 4. The u all over ds equals to 2x. Equals to what? 2x. Then we now have integral, what is it? 10x dot u dot the u all over ds, which is what here? 2x. Now we have this dx. Now, whereby we have this 2x here, 1, in 10x will give us 5, which will give us integral 5 dot u dot du. Then we have the x, which will now give us integral 5 u du, which will now give us integral 5 u du. This 5 will come outside, will now give us 5 integral u. The u we have here is raised to power what? Is raised to power 4. So you can put it 4, which is the power is raised to here. We should now have raised to power 4. Here, the u also. So we have 5 in bracket. This 4, when it comes here, to be what? 1 all over 4 plus 1 u 4 plus 1 plus c. Now, which equals to 5 in bracket 1 all over 4 plus 1, 5 u 4 plus 1, 5 bracket close plus the constant, which is c. 5 cancel 5, we have u raised to power 5 plus c. That is it. U raised to power 5 plus c. Now, what is our u? Our u will give us x squared plus 3, then say raised to power 5 plus c as our final answer. Now, we want to move further to definite integral. Definite integral we want to move to definite what? Integral. Let's look at 1 or 2 examples on definite integral. On definite integral. Now, we say that integral BA of f of s dx equals to f of x in this bracket BA, which equals to FB minus f of A. This is the formula we use in this. See now, integral superscript B subscript A f of x dx equals to f of x, whereby we have the b and a, fb f of b minus f of a. This is having 2 parts. For instance, let's take example so that we get more better understanding about it. Example 1 says integral 4 of 1 10 dx dx. If we are to solve this, the first thing you will first do is that forget about this definite integral. First solve for your 10x. First integrate your 10x. If you integrate your 10x here, what do you get when you are integrating 10x? This is, let me call it example 3, e.g. 3. Now, when you integrate your 10x, what do you have? Integrating this 10x will give you 10x. Integrating 10x, this is raised to power 1. 1 plus 1, 2. That's 1 all over 1 plus 1. 10x raised to power 1 plus 1 plus c. 1 all over 1 plus 1, 2. 10x raised to power 1 plus 1, 2 plus c. 2 here 1, 2 here 5, which equals to what? 5x raised to power 2 plus c. Now that you now have your 5x raised to power 2 plus c, you can now say 5x raised to power 2 plus c. You give it like this, then what do we have? 4 and 1. That means this will appear twice, which should now give us 5x raised to power 2 plus c minus the second one, which is what? 5x raised to power 2 plus c. This is the twice that's going to appear. This one, this 4, this x will be subtracted by this 4, while the x in the second one will be subtracted by 1. We will use 1 to replace it. Replacing this x by 4, we now have 5 in bracket 4 raised to power 2 plus c minus 5 s squared minus x plus minus 5s squared minus x plus a minus c. This one will now give you 5 in bracket 4 raised to power 2 plus c minus 5 in bracket x here is what? 1 raised to power 2 minus c. 5 in bracket 4 raised to power 2 16 plus c minus 5 in bracket 1 raised to power 2 1 minus c. Plus c minus c cancel each other. We now have 5 times 16. 5 times c is 30. Carry 3. 5 times 1, 5 plus 3, 80 minus 5 times 1, 5, which equals to what? 75 as our final answer. Let's pick another example on it. Still on this. The second example we will be looking at is this. Picking our second example, the second example says what? Second example, e.g. for second example on this definite integral says integrate 3 of 1 4x cubed plus 6x equals the x. Looking at this, how do we solve this? Now, I say the first thing is neglect this. Solution, forget about this integral, this superscript 3 and subscript 1. Forget this first. Firstly, integrate this. That is, integrate 4x cubed plus 6x dx. First integrate this, get your answer first before coming to touch this. When you are integrating this, what do you have? 4x cubed will give you, this is 4, x cubed, that will be bracket 1 all over, raised to power 3, you say plus 1, s raised to power 3 plus 1, plus, this one is 6, x, that will now be 1, all over 1 plus 1, sorry, 6, in bracket also 2, let us close this bracket, in bracket, 1 all over 1 plus 1, x, 1 plus 1 plus c. Now, we can now say 4 in bracket 1 all over 3 plus 1, 4, bracket close, x raised to power 3 plus 1, 4, plus, this will now give us 6 in bracket 1 all over 1 plus 1, 2, bracket close, x, 1 plus 1, 2, plus c. Now, 4 here, cancel 4 here. 1, we now have x raised to power 4 plus 2 here 1, 2 here 3, which equals to 3x raised to power 2 plus c. This is what we have here. So since we now have x raised to power 4 plus 3x raised to power 2 plus c, we can now put our subscript and superscript and subscript sign, which is 3 and 1. Now, making this equation to be in two places, we have x raised to power 4 plus 3x squared plus c minus, in bracket open, x raised to power 4 plus 3x squared plus c. This one will now give us x raised to power 4 plus 3x squared plus c minus x plus a minus x raised to power 4 minus x plus minus 3x square minus x plus a minus c. Now x is power 4. The first equation here, we use 3 to replace x. So that will now give us 3 raised to power what? 4 plus 3 in bracket 3 raised to power 2 plus c minus the second equation, we replace it with 1. 1 raised to power 4 minus 3 in bracket 1 raised to power 2 minus c. 3 raised to power 4, 3 times 3 times 3 times 3 in 4 places will give us 81 plus 3 in bracket 3 raised to power 2, 9 plus c minus 1 raised to power 4, 1 minus 3 bracket 1 raised to power 2, 1 minus c. Plus c cancel minus c. We now have 81 plus 3 times 9, 27 minus 1, 1 times 3 minus 3, which equals to 81 plus 27 will give us 107 minus 1 minus 3. 107 minus 1, 106. Oh, sorry, this is 108. So 81 plus 27, 108. 108 minus 1 minus 3 will give us 104. That is our final answer. Now, our final answer gives us 104. 1 plus 7, 8. 8 plus 2, 10. That would be 108 minus 1 minus 3, which will give us 104. That is our final answer here. Which says integral 3, then 1. I've said it means that whenever you come across questions like this under the definite integral, don't touch this first. Just solve, integrate this, which we have 4x cubed plus 6x. After integrating it, getting your final answer, then you can now come and touch this. Like when we get our final answer, if next x is power 4 plus 3x squared plus c, then we have 3 and 1. Now, the first one, we make it to be 2. The first one, we substitute 3 for x in the first one, while we substitute 1 for x in the second one. Substituting it, this is what we have. Then our final answer gives us what? 104. Thank you.